Today's lesson video, we are going to look at Mathematics 2611 Linear Algebra. We are going to discuss linear dependent and linear independent lesson 102. Let us start. Let us start with linear independent. There are many descriptions of what is vectors that are linear independent, but in this lesson video I'm going to discuss it generally so that you understand, because if you don't understand the language of linear algebra, it will be very difficult for you to understand linear independent or linear dependent. So to determine whether vectors are linear dependent or linear independent, we are going to use this equation. This equation consists of the sum of vectors, which each vector is multiplied by a certain scalar value, and then looking at the sum of that operation, it's equals to 0. Now if it happens that we multiply each and every vector by a scalar value, for instance k1 multiplied by v1, v1 is a vector, k1 is a scalar, plus another scalar multiplied by the second vector v2, plus another scalar multiplied by the third vector v3, up to kn multiplied by vn. And then we discover that the left hand side is equals to the right hand side, meaning that this operation is equals to 0, because you can see that the right hand side is also equals to 0. So for the left hand side to be equals to the right hand side, the left hand side must also be equals to 0, meaning that this whole operation will be equals to 0. If this condition is met, then we say v1, v2, v3, vn, they are linear independent. Now check. The only way to satisfy this condition, k must be equals to 0. In fact, all the values of k must be equals to 0, because 0 multiplied by v1 plus 0 multiplied by v2 plus 0 multiplied by v3 up to 0 multiplied by vn, we do agree that this will be equals to 0 plus 0 plus 0 plus 0. Then the sum of all the zeros will be equals to 0. We'll end up having something like this. So for linear independent, the values of k must be 0. Let us look at an example. Show whether these vectors are linear dependent or linear independent. We need to start by writing the equation k1 v1 plus k2 v2 plus k3 v3 is equals to 0. For now we end up at k3 v3 because we have 3 vectors. Now we have k1, our v1 is 1, negative 2, 3, plus k2, 5, 6, negative 1, plus k3, 3, 2, 1, equals to a 0 vector. Now basically we need to show or prove that k1, k2, k3 is equals to 0. Then if we find that k1, k2, k3 is equals to 0, then we are going to conclude that v1, v2 and v3 are linear independent. Then if k1, k2, k3 is not equals to 0, then the vectors are linearly dependent. From here we need to write it in a matrix form, augmented matrix form. This is supposed to be 6. It's very important that you know how to use Gaussian elimination operation or row operations. We need to transform this matrix into a raw echelon form, meaning that we need to obtain zeros from these entries. Our first operation, 2R1, we are going to multiply row number 1 by 2 plus row number 2 to give us row number 2. So it means nothing will happen to the first row, 1, 5, 3, 0. And then we are going to change row number 2. So how do we change? We are going to multiply 2 multiplied by 1, it's 2 plus 2, which is 0. 2 multiplied by 5, it's 10 plus 6, it's 16. 2 multiplied by 3 is 6. 6 plus 2, we have 8. Then we still have 0 there. Row number 3 will remain the same. We need to perform a row operation again. 3 multiplied by R1 minus R3 to give us our new R3. So meaning R1 and R2 will remain the same. 1, 5, 3, 0, 0, 16, 8, 0. Now let us perform the row operation. 3 multiplied by 1, it's 3, minus 3, we have 0. 3 multiplied by 5, it's 15. 15 minus 1, it's 16. 3 multiplied by 3, it's 9. 9 minus 1, we have 8. Then we have 0 here. This is our new metric. We can see that we have 0, 0. We need to have 0 again here. So what is the operation that we can perform in order to obtain that 0? We can see that row number 2 and row number 1 are identical. So we can simply say R3 minus R2 to obtain our new R3. Row number 1 will remain the same, 1, 5, 3, 0, 16, 8, 0. Then from here, 0 minus 0 is basically 0. 16 minus 16 is 0. 8 minus 0 is 0. Then we have 0. So from here we can see that we have obtained the row echelon form. Now from here we can simply conclude that the value of K3 in this case, since we have all the zeros from R3, will be a free variable which is T or you can say k3 is equals to x, any variable is fine. And then k2, we are going to have, since we have 0 here, it means k1 is 0, k2 is 16 plus k3, which is, okay, we are going to back substitute equals to 0. Then from here, 16 k2 plus 8t is equals to 0. And then solving for k2, we have k2 is equals to negative 8t divided by 16. Then basically this is equals to negative 1 over 2t. So this is the value of k2. This will be the value of k3. Now let us solve for k1. From here we have k1 plus 5k2 plus 3k3 is equals to 0. Take it from here. So we have k1 plus 5k2 is equals to negative 1 over 2t plus 3k3 is simply t equals to 0. So k1 is equals to, actually it's negative 5 over 2t plus 3t equals to 0. k1 is equals to positive 5 over 2t minus 3t, and then k1 is equals to 1 over 2, actually negative 1 over 2t. So we can see that the values of k are not zeros. In this case, we can conclude that v1, v2, and v3 are linear dependent since k is not equals to 0. You can see that the value of k is negative 1 over 2t, k1, k2 is negative 1 over 2t, then k3 is simply t. Sometimes you might hear the term non-trivial. So these values of k are not trivial, they are non-trivial. For the next activity, I leave it for you. Prove that v1, v2, v3 are linear independent. That's it for this lesson video. This is Wahula SJ. Thank you very much.